Okay, let's get started. All right, last time I worked on this example of a custom type, and the reason I did this is I go back to my original project. Let's see. Uh, Oops, there's stage. Connect to server. There we go. That should do it. We'll open it in a new window. So the reason I did that is so that I could take the example that I have here that I know works and migrate it to this my main project. And so what I have here is what I thought would be the correct way to do it, but it turns out it's not after figuring it out actually. So even though the calls all kind of make sense, some of the items do not in fact are not in fact correct. That's good coffee. So let's go ahead and fix this. So if we look at my my pool, so this part is correct. So through the pool opening and the after connect, that's fine. And through connect config is fine. What's not fine is this piece in here. So we're just going to go ahead and take the code from here and we are going to go ahead and just paste it in here. Alright, so let's close this and we'll focus on this. Now, we do actually have a resolution type in this project. I want to say it's a metadata service. Yes, there it is. So the difference is this is a room. Okay, so we've got the resolution type, and this is now the correct way of doing it, where we get the OID for that type that was assigned by the database when the type was created. We created a new composite type and we registered. Okay, great, fantastic. So now when we get a connection to the database, we have our resolution. And we have BIME type. And finally, we should have a hash. There we go. So let's go back into the metadata table and take a look at our columns. So we've got the date capture. All right, we're good. We've got the date captured, the location, the runtime, the tags, date, tags, location, runtime. The locator is in a separate table, but in this case we go ahead and hydrate it back into metadata. Resolution, MIME type, and hash. All right, so now we need to fix our tests. So let's start with let's start with this one. So this is going to return MIME type and so let's go ahead and add these in. So the file hash, I'm just going to make up a number, ECD1234. MIME type, we're going to go with MIME JPEG, and we're going to go with resolution, and we're going to go ahead and fill all fields with, say, 1024, height 600, scan, and that's going to be a rune, which I'm going to go and say it's progressive. We'll just use the same thing on all of them. And we'll do the same thing here. Okay. So the select should contain LPath. I'm going to go, so we've got hash mime type file hash mime type resolution. There we go. This should return. Let's put a pin in that one. Okay. Let's go fix the other ones. All right, so now if we run our tests, they should fail. Could not match SQL. That's right, because our SQL that we're executing does not match that. So let's go back to data service. And let's go to my SQL. Actually, let's go to Metadata Query Builder. File hash yep. I'm type and resolution. So now let's run our tests. Now we have more test failings. Expected. Tags, file hash, MIME type resolution. Let's actually copy this because I am tired of typing it in all the time. Let's run our tests. Okay. Find by ID. Unexpected error when true. Incorrect argument number 7 for columns 10. Find by ID. So find by ID executes a query and then processes rows. I believe they're all pretty much the same pattern, so really we're talking about is fixing this. So we've got var file hash var mime type var. Okay. Path. Okay. Metadata doesn't have those fields. So let's go to metadata. Oh, it does have those fields. Hash equals file hash. MIME type equals MIME type. Now let's try our tests. Cool, we're passing. Okay. All right, so we've got a couple of warnings here I'd like to clean up. What are these? Unused constant, that's fine. Unused parameter CTX. That's right, we have a save that we need to implement at some point, but not yet. Okay. And we've got some unused constants, but we expect to use those in the future. Okay. That's fine. Rename. This would just be DBURI. Okay. Typos. We're not going to worry about it. Okay. All right. So we've added our fields. We're now passing. So let's talk a little bit about naming. So if we look at this now, there are some things in here that are definitely metadata, right? So there's date, tags, location, runtime. Those are all metadata, right? So the date that something was captured wouldn't change if we re-encode it into something else, right? So the wedding in June, I took my video, wedding was still in June, even if I later transcode the video, 6 months later to Og or something, right? So the date doesn't change. The tags really, would I put in different tags for a different coding? Maybe. But I think the way I'm intending to use tags, it would be more at the level of like the tags would for that wedding video would be wedding, cousin Ann, funky chicken. Location wouldn't change, right? That would stay as Nantucket or whatever. And if it's video, the original video runtime wouldn't change, but if I make a derivative video with a different encoding, it might have it like I could crop the video, or I could edit out the part where cousin Ann, gets drunk and hits on the waiter. Locator would change depending on the file and encoding, right? So this is, let's make this immutable. Consider tags immutable. Locations immutable. Runtime, not sure. This is file specific. This is file specific, right? The MIME type is file specific, and the hash is file specific. So I've really mixed two concerns in the same thing. So I've got duration, which is kind of, interestingly enough, it's on the border between the two, but runtime for a video, never change for a file, for an image, right? Because an image doesn't have runtime, but for a video, I could crop a video down. It's still the same video of the same thing, but it's shorter. So I'm going to go and put that as file specific. So it's a video of the same event, taken at the same time, taken at the same location. It's the same video, I've just cropped off the end where, cousin Vinny decides to vomit all over the bride's wedding dress, or whatever. So I've got the file specific portions, I've got the immutable portions, so I've got two separate concerns in the same thing. So what I really have is that's truly metadata, right? And then what I have is data. So what I really have are two separate concerns, right? So in theory, so this might look something like as the key, right? So, and then I've got right, I've really got a one-to-many. So implicit in this is I have a metadata ID on the table, and this, of course, because it, and so implicit in this is the notion of data So that's not really mutable, but you get the picture, right? So metadata is related to data. Data is a locator. So let's see. So what I call it data, it's a stream of binary data that represents a construct of an image. Yeah, sure. So I had kind of like locations while we've got this open for surgery. Actually, I won't work. So yeah, I think we have some fundamental surgery we need to do on these objects. So potentially, our result sets for metadata, when we go to query for the metadata, our result sets would be something like metadata, something ID, date, tags, location, data.id, data. Just do d.id, d.runtime, d.resolution, d.time type, d.hash, l dot id, l dot, well, just name and file location, right? Where's locator? Source and data. Actually, no, this is type and path. Okay, so I would have something like 1:05:01:2020. Tags might be foo bar. Right. Location, home, 7, 0, and this is 1024 by 600p. And the MIME type would be image JPEG. Hash would be ABCD1, 2, 3, 4. And the location ID would be it's a 10. Location ID, date ID would be 7. The type would be file, and the path would be foo.bar.jpg. And so the next one would be 2. That would be 05. Or no, sorry, this would be another one. 05. Data ID would be, say, 7, 0. And the next one would be still 1. Home. Say data ID 8. And this one's at a different resolution. Let's say this is 496 by 2160 progressive. Let's see, 1, 2, 3, 4. This is 12. It's 8. Okay. So that would represent one metadata with 2 encodings of the same data. Maybe this should be called encoding. So it's a metadata with 2 encodings of the same data. So one is a JPEG and one is a TIFF. There are 2 copies of the JPEG, but only 1 copy of the TIFF. Okay, so this next one would be make life easy. And let's say this runtime is 35 seconds and the resolution is so the resolution is progressive, and this would be do I have I think mobs are just MP4s. And location ID, data ID is 9, and it's a file, and it's under foo, and let's call it some.mov. Okay. Locations work. Data ID is 10. I cut out 10 seconds of it. still 1920 by 1080. Video and MP4. Different hash. It is location store versus date item 10 archive. Okay, so this next example is where I would have two encodings of the same video. Let's say DV. And finally, let's say the resolution is okay. So this would result in 3 metadata records. And they would be 2 data records. So it'd have three metadata records. One, 2, and 3. One would have 2 encodings. Where encoding 1 had 2 copies. Okay. 2 would have 2 encodings with 1 location each. And finally, metadata 3 would have 1 encoding in 1 location. Okay, so I think that is the model we want. That's the result we want. And so we'd have, so our control break processing would be, take this result set, we sort by metadata ID, then let's call this encoding. Get rid of this because it isn't necessary. No, it's not shift, is it? Nope. What is it? Nope. There was one that let me select vertically. Anyway, it's not necessary. The column. So the first control break would be on the metadata ID. The next control break would be on the encoding ID. So as I'm pulling this back from the database and I'm, excuse me, getting back the metadata, what I want to do is I want to cycle through the metadata, and then when I had a new encoding ID, I've got a new encoding. So add that encoding to the metadata record that I'm processing. And while I process each row, I add locations to that encoding. So initially I set my metadata ID to 1, my encoding ID to 7, and I process this location, move on to the next one. This hasn't changed, so I process the next location. This has changed, so I take this location, I create a new location, and add this encoding to the new location. Next, this changes, so I start a new metadata record with a new location or new encoding, process any locations. So there are two control break. You might be saying, why don't you just query the metadata and then for each metadata query that? So the reason is we want to minimize the number of round trips we take to the database, generally speaking. This is not always true. Sometimes we want to load things lazily. A good example of wanting to load something lazily is, let's say we had, in addition to these fields, like a write-up. Like we had, some large text field, which was the history of the image or whatever. We might not want to bring it back in this result set because it could be very large. And so that we might want to pull back in a lazy fashion. So we would say, okay, we're not going to bring it back now because we rarely use it because it's so big. We'll load it later when we need it. But generally speaking, you want to minimize the trips to the database. So think about this. Let's say, for example, this query to parse and execute and return results took 100 milliseconds. It could be that that we have a whole bunch of images, and well, it could be of that 100 milliseconds, say 75 milliseconds is specific to this query, and 25 milliseconds is just roughly the overhead of getting back and forth from the database, etc. So if we take multiple trips back to the database, we wind up adding more and more time to process the data, which means that instead of taking 100 milliseconds to process the result because of each round trip, I'm adding a certain amount of time to this. So let's say I have 10 round trips to make, I add a quarter second to my processing. So rather than do that, we try to get everything one shot, and these are all kind of reasonable fields to bring back together, right? So dates, tags, location, these are all intended to be shorter things. So they should be fairly compact. So yeah, so if we, so even an ORM, so let's say we're using an ORM, even an ORM would probably use this strategy to kind of bring back all the metadata, complete with its related encodings, complete with the location of each encoding in one fell swoop. And then would rehydrate those structures using pretty much some variation of the control break method. That would be my guess. I've never really implemented an ORM. I've seen many ORMs abused, which is why I'm writing my own SQL, but I've never actually implemented an ORM. Well, kind of. There's one project I worked on where we kind of implemented an ORM in C++, but I think the queries were largely fixed, if I remember correctly. It was more about swizzling in the data and swizzling out the data. You know, we've got some other things here. Would we ever search for encodings? Would we ever sit there and say, I want no. Yeah, the one thing I could kind of see is maybe searching by MIME type. But you probably still want to bring back this information as well. So we could add MIME type here. And it would never make sense to query on a hash. That just, I doubt that would ever be a reasonable thing to go seeking other data on. Okay. Okay, well, you know, I'm going to call it a day here, but we've got a lot, or I've got a lot of work ahead of me to split this into a metadata and encodings. So these we can comment out for now because they're just broken. So we've got, just going through here, we've got then for find, So we're going to add find by MIME type. Ray didn't like that, did it? Okay. Ostensibly, this wouldn't change. This probably wouldn't change. Probably wouldn't change. Okay. Query builder. We need to add the okay. So if I go back to metadata service, what do I have in the test? So the test needs to be fixed. Okay. We need to fix to do. Just comment all this out. All right. Almost done with this. What I'm doing right now is I'm just going through the file to see what I need to change in the test. Now, we're going to comment out a bunch of stuff. We're going to comment out a bunch of stuff to get things working again. And we'll have to go back and fix it, but we're going to start by peeling back the onion at the query builder, right? So the root of it is the query builder, and we'll move up from there. So once we're happy with the query builder, we'll attack the tests in the metadata service. That will split it in different ways. All right, so there's a whole bunch of fix me's and do this and to-dos. All right. Well, pitter patter, let's get at her. So we got metadata ID, date captured, location. So we are going to have a new table. This table is called encoding. It's going to have an ID, and it's going to be a big int, and it's going to be next val seek identity seek. There it is. Okay. Next column. We're going to have a metadata ID. It's going to be a big int. And right now we're just going to set it as not null. And then we're going to have a runtime. Runtime is going to be time. And then we're going to have a resolution, type as resolution. And then we're going to have a MIME type, which is a string or varchar. And we're going to have a hash, file hash. hash, which is varchar. Foreign keys. So encoding metadata fk, target table, metadata, update rule, delete rule, cascade, and we want from metadata ID to ID. Execute. Okay. So there's our encoding table. So we got some stuff coming off here. So metadata, metadata, modify table, there we go. So we're taking these three off. Date captured, tags, runtime is coming off. So date, captured, tags, location. Okay. Now let's go to the locator table. And we're going to modify this table. Locator is going to continue to have an ID. So let's get rid of this foreign key first. Let's get rid of these key indexes. Okay. So this is going to have not a metadata ID, but it's going to have an encoding ID. Big int, not null, foreign key, locator, encoding, target table, encoding, delete rule, cascade, from encoding ID to ID. Okay, so we can't mark this as not null yet. Cannot drop index locator pk because constraint locator pk. Indexes. Okay, I'm going to lose my changes. So let's go back to modify. Modify table. Okay. So this needs to go, right? So get rid of that. Get rid of that. And then we say cascade. Okay. So now we have our data is in the right shape. So that's our metadata. This is our encoding. This is our locator. So we can go ahead and we can drop these. Actually, let's make an encoding. Insert into encoding. Oh, that's old. So we used and runtime is no longer there. Okay. And so what we really want to do is insert into encoding values that is defaulted, right? We'd probably set a nil for runtime if it doesn't apply. So resolution. Postgres insert object literal. Please tell me. Oh yeah, I'm live streaming. Good. I've done it before. I thought I started a stream, and I in fact didn't start the stream. And then later on, I was done with the stream, and I was like, oh, my data went nowhere. So let's take a look. Insert custom type. Oh, okay. Create type. Hmm. Oh, I see. Okay. Okay, I want this one to have 2 encodings. And this one, I want to have 1 encoding. Okay, so let's go ahead and execute this one. Okay, let's execute this one. Okay. Oh yeah, this changes. Because those all point to the same. Nope. Okay. This is going to have 2. Okay. So inner join L a metadata. Inner join, so this is going to be encoding on right? Okay. I think that's what I want. Yep, that's what I want. No, I want my console back. So I've got metadata. Yep. 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 I'm drawing a blank on multiple inner joins. Nope, I want that. Oh, that's fine. What if I got 3 tables? Yeah, so inner join payment on payment.customer.id equals customer.customer ID. Inner join staff on staff equals, so that, okay, yeah, that's what I want. I have my syntax right. Inner join locator L on encoding select start from metadata. So metadata has 2 rows, 537, 538. Encoding has 537, 538. So there should be 3 so far. And coding has 542, 543, 444. Four two four three four four. Nope. Okay, let's go back to there we go. Okay. So if we go to the query builder, just go to console, grab this, right? So the query builder test, so let's start with this one. We would expect inner join and another inner join. And we would expect metadata, date captured, location, runtime, now, next we want our encoding ID. Runtime, solution, type. So, okay. So let's actually drop the E here. And let's drop the L here. It's a little bit more verbose, but it's easier to keep track of what we've got, right? And this is what I want. So if I take this, take this back to the console, I should have correct query. Yep. Yep. Okay, so I've got a good query. Let's just add that fragment in just to make double sure we've got a good query. See, I misspelled order. There we go. Okay. So if I run this test, it will fail, because that's not what the builder is building. Okay. So let's clean this up so it looks pretty. Let's see, did that fix it? No, because we don't have our... Now let's see if that fixes it. Okay, let's go see what's wrong here. Nope. So I just need to find out why they're different. Date capture location tags. Encoding ID, encoding runtime, encoding resolution, encoding mine time, file hash. Locator ID, locator source, locator path from metadata. And are the inner join clauses the same? Yep, the inner join clauses look to be the same. Metadata ID equals 1. We don't have our order by clause. So where is that? It's stuck in down here. So where's find by ID? qb.add front matter. Aha! Now let's run it. Okay, let's see why they're different. Oh, let's also correctly escape the nope, we're not escaping here. So find by ID is a little bit different from the rest of them. And that is why you make everything the same. Or try to. Let's see. This all through here should be correct because that really hasn't changed. So let's take a look here. Oh, right, we've got doubled up on the where clause. So we really do not want that. Okay. All right, cool, we got a passing test. So what changes, I expect order by clause to change. And I expect front matter to change. Okay, that passed. Expect front matter to change. I expect the order by to change, but I don't expect anything else to change. Same deal. Probably a better way I can do this. And we're just going to keep fixing tests and running individual tests. Actually, let's make sure this is still failing. Yep, so let's fix the test. So it's not really the select and inner join stuff we're testing here. It's more the creation of the where clause that these tests are testing. But unless the front matter and the back matter of the query is correct, our test won't work. We didn't really change the way any of these numbers were being added, so I wouldn't expect any of these tests to really break, except for the fact that the target criteria has changed, so that would cause the test to fail. But in reality, we haven't really changed any of the underlying mechanics of assigning these where clauses. Okay. So it looks like the query builder is working. So we have a new one, which is by MIME types, and so that is going to take n types. So we're just going to stub that out for now, and let's go to my test by MIME types. So we've got and we want to do query by MIME types, and say there are two types, and we're gonna. So what should should this look like? So this should look like that doesn't change. This doesn't change. This does change. Where, and I think it should look like where encoding.mime type is equal to $1 or Failed, yes, that's right. We expect it to fail. So let's talk about how this should go. This should go be, so we call QB to add front matter as we do in all of them. And we want it to be a parenthesized expression. And at the end we need to okay. Nope, that's not. Now let's run the test. Now let's run the test. Okay, so by MIME types is in there. And let's just make sure that this is a valid query. So let's take it back to our console. Where encoding.MIME_type is equal to, let's say, image TIFF. So if I run this, I should get at least my TIFF. Yes. And how many TIFFs do I have? I just have one. Okay. All right. That is Query Builder. Now let's take a look at the metadata service. I am going to save this for tomorrow now that I've got the Query Builder done. This one is going to be a bear. So looking back at our query, what is this? This row doesn't look the same here. It looks different. And we've got different control break processing. So yeah, it's going to be a bear. So I will see you tomorrow. Oops. Let's